Okay, so this is the assessment on probability and binomial distribution. So the first thing we're going to look at is this question 1. It says, determine which of the following statements is most true for the event a student passes both AS Maths papers. Well, passing both papers are definitely not mutually exclusive, because mutually exclusive means that the two things can't happen at the same time. Well, we can definitely pass both of them. So that means I can rule out this one and I can rule out this one. So they are not mutually exclusive. They can happen. Independent means that passing one doesn't affect passing the other one. But I would argue that if this is a maths student and they're good at maths, and we know that topics which come up on our pure part of the paper do have an effect on our applied part, like for example logarithms has shown up a little bit recently with the binomial distribution, then they are not independent either. One will affect the other. Okay, question 2. So the probability of A is 0.3, the probability of B is 0.25. Given that they are mutually exclusive, this means they cannot happen at the same time. Find the probability of A and B. So that is the intersection, the probability of this middle bit here where both of them are occurring. But I've just said they can't happen at the same time, so that has got to be 0. This means the probability of the complement of B, which means not B happening. So not B, and because this middle bit is 0, is going to be 1 minus 0.25, which will give me 0.75. This means A or B or both. We don't have a both bit again. And when we have or in probability, we just add them. So 0.3 plus 0.25 gives me 0.55. And are events A and B independent? Well, if events are independent, so if they are independent, the probability of A times by the probability of B equals the probability of A and B. Well, A times B is going to give me 0.075, and A and B equals 0. So that doesn't equal, so they are not independent. Okay, so that's a really important fact that we need to remember. If they are independent, then this is the case. Question 3. So Nasia is playing a game with two friends. The game is designed to be a game of chance, so the probability of Nasia winning each game is 1/3. Nasia and his friends play this game 15 times. Find the probability that Nasia wins exactly 2 games. Well, this is a binomial distribution where n is going to be the number of games Nasia wins. And we're going to say then n, or you could have used x, is binomially distributed. He plays 15 times, so my number of trials is 15, and my chance of winning is 1/3. So I want the probability he wins exactly 2 games. So that is just the probability of n equaling 2. And I'm going to type that into my calculator. So I'm using this one here, menu, distribution. It's binomial PD. So 4 is just one variable. So 2. My x is going to be 2. My n is 15. And my probability is 1 over 3. So that is 0.05995 to 4 significant figures. Okay. The probability then that he wins more than 5 games. So I want the probability of n being greater than 5. Well, I can't find that out on my calculator. So let's think about this. If I had an inequalities line and I wanted these section of numbers here, that is the same as 1 minus 5 and everything below, because remember this doesn't include 5. More than 5 does not include 5. So it's the same as 1 minus the probability of n being less than or equal to 5. And I can do less than or equal to 5 on my calculator. If I go back onto menu and distribution, we go down this time and look at binomial CD, cumulative distribution. I just want a variable. My n is 5. Everything else is the same, and that is 0.618371. But it's 1 minus that. So we'll go back, set up 1 minus answer 0.3816 to 4 significant figures. Okay. Question 4. So the probability for the number of days in a week that Ahmed's mobile phone battery runs out before the end of the day is modelled by this table. Find the value of x. Okay. So these here are going to be the probability of just x equaling x. It's not cumulative, which means that all of these are going to add up to 1. So I'm just going to form an equation, and they add up to 1 because one of them has to occur. So that will give me equals 1, sorry. 3x plus 0.46 equals 1. So I can rearrange 3x equals 0.54. So x is 0.18. Okay, next question. The two-way table shows the breakdown of employees in a company. Senior managers and employees are mutually exclusive categories. Okay, so you can't be a senior manager and a non-management staff. You can't be both of those. And that makes sense because 130 plus 15 is 145. That plus that is that, that plus that is that, etc. Find the probability that the employee is female. So I'm looking at my total female, 125, and just everyone in the company, 270. And we don't have to simplify it. Find the probability that an employee, so any employee, so it's out of 270 again, is male and a senior. So male and a senior is this one here, 15. Determine whether an employee being female and being a senior manager is independent. So remember what I said before. Something is independent if the probability of A and the probability times by the probability of B is equal to the probability of A and B. So I'm going to say being a female is A and being a senior manager is B here. So the probability of being a female is 125 over 270. And the probability of being a senior manager is 18 over 270. Now when I times those together, that gives me 5 over 162. So let's actually work out the probability of A and B. So that's the probability, excuse me, of being female and a senior manager. So female and a senior manager is 3 over 270. But I can see straight away that that does not equal that. So they are not independent. Part D. Given that the employee picked is a senior manager, what is the probability that they are male? So I've got a senior manager that's been picked. So that means my denominator is going to be 18 because I've got 18 to choose from. The probability that they're a male, there are only 15 of those, so 15 over 18. Question 6. A festival decides that it will allocate tickets based on a lottery system rather than a first come first served basis. It has 3 deadlines with a fixed number of applications and tickets for each deadline. The chance of getting a ticket reduces for each deadline. 3 friends apply and each one ends up with a different deadline. Find the probability that all 3 friends get tickets. So let's just say that's friend 1, that's friend 2, and that's friend 3. Well, I want the probability of friend 1 getting a ticket. It's going to be 0.8. And so I'm times in friend 2, which was 0.6, and friend 3, which was 0.3, which is going to give me 0.144. Okay, find the probability that exactly 2 of the friends get tickets. So if we think about this as being a tree diagram, where each friend, we'll do friend 1, friend 2, friend 3 again, getting a ticket. Well, friend 1, let's say they get a ticket or they don't get a ticket, so ticket or no ticket. Friend 2, ticket or no ticket, ticket or no ticket. And friend 3, ticket, no ticket, ticket, no ticket, ticket, no ticket, ticket, no ticket. So I want my options where only 2 of them get a ticket. So it could be this one here, ticket, no ticket, ticket. It could be no ticket, ticket, ticket. Or it could be, well, they're my only options. I think ticket, 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 no ticket. Oh, sorry, and there was another one here. Okay, so that is the probability then of ticket, ticket, no ticket. You don't have to draw a tree for this. It's okay if you just realise these combinations that we had before. And remember that the probabilities are going to change for each of them. So for the first one, the probability of getting a ticket was 0.8. So that means not getting a ticket was 0.2. So I'm doing 0.8 here, 0.8 here, and 0.2 there. For the second one then, the probability of getting a ticket was 0.6. So it's 0.4 for not getting a ticket. So that's times by 0.6 because I had ticket on my second one, no ticket on that one, so 0.4, and ticket on that one, so 0.6. And then last one, the chance of getting a ticket is 0.3, and the chance of not getting a ticket then is 0.7. I'm not going to write them for each of them. They're the same. So no ticket, 0.7, ticket, 0.3, and ticket, 0.3. So we will times those, and then because it's this or this, whatever my answer is that I get for each of these, I'm going to add them. And that gives me 0.504. Okay, question 7. Sorry. Question 7. So, in a game, a player can score 0, 1, 2, 3, or 4 points each time the game is played. We've got this distribution table, and it says each game is independent of the previous game. Great. And the probability of x being less than 2 is the same as 2 times the probability of x being greater than or equal to 2. So let's just think about that first little bit. So the first thing I know, because they're independent, is that all of these are going to add up to 1. So I'm going to form an equation, a plus b plus c plus 0.1 plus 0.15 equals 1. We'll just rearrange that to tidy it up a little bit. So I'm going to take away 0.25 from that side, so 0.75. Okay. Now I'm going to use this fact. The probability that x, should say s really, is less than 2 is equal to 2 times the probability of x being greater than or equal to 2. Sorry, just saying x. Okay, less than 2 means it's either 0 or 1. So that's going to be a plus b. 2 times the probability of x being greater than or equal to 2 is these 3 probabilities, 2 or 3 or 4. So 2 times c plus 0.1 plus 0.15. So we'll tidy that up. Okay, so what I've got now is I've got 2 equations. And I can use those 2 equations as simultaneous equations, but not like really that we've seen before, just to find out one of the values. And because I've got the a plus b equals this, what I can do is I can substitute in a plus b in here. So I'm going to substitute into here this, because that equals a plus b. So that gives me 2c plus 0.5, so I've replaced that, plus c equals 0.75. So 3c plus 0.5 equals 0.75. So 3c equals 0.25. So c equals 0.25 divided by 3, which is 1/12. And I'm going to leave it as a fraction because it's much nicer. Okay, now I've got really no way of working out a or b, so I'm hoping that the question doesn't want me to do that. I know I haven't really read even what the question wants yet, but I thought there was going to be something to do with that. So let's have a little look. John plays the game twice, and the scores are, and adds the 2 scores together to get a total. Calculate the probability that the total is 6 points. Well, firstly, I need to think about what combinations I'm going to have that are going to get me a 6-point total. So let's have a look. He can get 0, 1, 2, 3, or 4. He plays the game twice. So my only options are going to be, well, 0 and 1 are going to be discounted because I'm not going to add anything to that to get 6. So my only options are that he scores 2 and 4, or he scores 4 and 2, or scores 3 and 3. Okay, so that will be, for this probability here, Well, a probability of 2, I've just worked that out, is 1 over 12. So that's 1 over 12 times by 0.15. This one is going to be exactly the same the other way round, but it will still give me the same answer because I'm multiplying. And then that will be 0.1 times 0.1. So that gives me 1 over 80, 1 over 80, and 1 over 100. So the probability of scoring a 6 is 1 over 80, add 1 over 80, add 1 over 100, which gives me 7 over 200. Which is 0.035. Okay. Okay. Question 8. So Sophia collected data about the weekly consumption of fromage frais in grams from samples of residents of 2 English towns. We've got some values listed in the table. Calculate the appropriate measures for the 2 towns. Well, based on what they've given to us, it's going to make sense to find the mean and to find the standard deviation. So I'm actually going to call, well, it doesn't matter. So let's have a little look at doing this. So town A, well, if I want the mean for town A, it's just all of those values added together divided by how many there are. So the mean, x bar, is just going to be 199 over 10, which is 19.9. My standard deviation then for town A is going to be root of the sum of x squared divided by how many there are minus the mean squared. Okay, so we've got the sum of x squared 3993 over 10 minus 19.9 squared, which is 1.814. And then exactly the same thing for town B. I'm going to let you work that out. The mean, and you can check your answer, is 14.3, and the standard deviation for B is going to be 3.874. Okay, so B then says, hence explain the differences in the consumption of fromage frais suggested by this data. So I'm going to show you the mark scheme for this. I'm going to show you where what exactly they were saying that they wanted to see for this. Okay, so they were saying that people in town A tend to consume more fromage frais than town B, and that is because the mean for town A is larger. So they consume more because the mean is larger. You didn't have to write that. Sometimes you will need to. The second comment then links to the standard deviation. So the fromage frais consumption of people in town B tends to vary more than town A. And that's because town B has a higher standard deviation than town A. So because the standard deviation is higher, it's going to vary more. Okay. And question C says, comment on the likely reliability of your conclusion. A lot of people got this, but 10 people is not really enough to ask. So we would say sample sizes are very small, so the results may not be reliable. Important we say they may not be reliable. They may, but it's unlikely. Okay. Thank you very much.